Hi, everybody. So just going to go through quickly some 4 topics from radicals that you may have forgotten. First 2 are just basic simplifying radicals, and yeah, we'll go from there. So let's just get started. You're going to need these the rest of this unit and actually beyond. So here we go. I'm going to do a factor tree. You may have learned it a little differently with a different teacher, but if you did, let me know in class and I can show you. But this is the way I teach it. So 2 numbers that multiply to 54. I know it's 9 and 6. You can do any 2 that multiply. So 2 and 27 would have also worked. And then keep going until you get to a prime. So 9s can get broken down into 3 and 3. I circle those because they're prime. I can't go any further. And 6 is 3 and 2. Both of those are prime. And now what I've done is I've rewritten 54 as the product of all of its prime numbers. You may start to remember this. Hopefully you do. I can now split those up, and I'm going to split them up strategically. I'm taking these 2 and putting them together under 1, and I'm taking these 2 and putting them together here. The reason I like this one is because it's got 3 squared, and you know that the radical and the squared cancel. So that's left, that gives me a 3 that's on the outside of the radical. There's nothing paired here, so I can't do anything with that. That just gets multiplied back together and is just radical 6. So my answer on this one is just 3 radical 6. Right. Number 2 is a lot bigger number, but same process. I know it's 36 and 10. 36 is 6 and 6. 10 is 5 and 2. Those are both prime. 6 is 3 and 2. And 6 is 3 and 2. You could write it out the way I did here, or you can just look for pairs. Hopefully you notice that pairs, right, are what we want. So I've got a pair of 2s, which makes a 2. I've got a pair of 3s, which makes a 3. And I've got an unpaired 5 and an unpaired 2. Those go back underneath the radical. And this is all multiplication. So it's going to be 6 on the outside, radical 10 on the inside. And that's the answer for that one. Okay. Second topic is still simplifying radicals, but this time with multiplication. So with this one, all I'm going to do is I'm going to multiply outside stuff together and then inside stuff together to make one big radical. So 8 times 2, 16. 6 times 3, 18. So now that is gone, and my new problem is 16 radical 18. Now 16 is already on the outside, so I'm not going to do anything with that except for keep track of it. Now I'm going to focus on just the square root of 18, which is what we just did. We'll do this quickly now. 9 and 2, 3 and 3. That's a pair of 3s, so that's 3 radical 2. So I put it inside the parentheses, whatever that simplified down to. And now I just multiply 16 and 3 and say 48 radical 2. Okay. The next one, a lot of people get confused by this one. If you type it in the calculator, you'll probably get, if you type it in the calculator incorrectly, you'll probably get 35. 35 is not the answer here. Keep in mind what squared means. It means 5 radical 7 times itself. So 5 radical 7. If I multiply those together, I get 25 radical 49. Now, hopefully you know your perfect squares by now. Always watch for those. The square root of 49 is just 7. No radical anymore. 25 times 7 then is 175, and that is the correct answer. No radical here at all. Okay, that's the second topic. Third topic, one of the most confusing ones for a lot of people is the division part. And unfortunately for you, that's going to come into play a lot with this first lesson in Unit 9. Okay, so here we go. Rule with this is you can't have a radical in the denominator. In both of these, I have one. So I've got the square root of 8, and I'm just going to go ahead and split it up over the square root of 3. I can't reduce that. Square root of 3 is not a good number. So what I'm going to do is I'm going to multiply by a fancy, I call it fancy 1. Reason I call it fancy 1 is because square root of 3 over square root of 3 is just 1, and it's written fancy because it's got a radical in it. But when I multiply by 1, I don't change the value of a number. All I do is change how it looks. So that's why I'm doing this. I'm multiplying the top and the bottom by the same thing. Why? Well, the bottom becomes the square root of 3 squared. I got a pair under the radical, makes just 3, and the radical's gone. The top, 8 and 3 are both under the radical, so I can multiply those together. Now, almost done, but now I got to go down and simplify the square root of 24. It's 4 and 6, 2 and 2, 3 and 2. So that is a pair of 2s and a leftover 3 and 2. So those get multiplied back together to make 6. So that's what this one is. If you want to check, type square root of 8 divided by 3 in your calculator. You'll get a decimal, and then do the same thing. Do 2 radical 6 divided by 3. You should get the same decimal. Number 6, a lot of people think, oh, let's reduce this right away. You can't. 10 is outside the radical, 2 is inside the radical. So what I need to do is I need to go ahead and do the fancy one again, multiplying top and bottom by radical 2. 10 is outside, 2 is inside, so I cannot combine those. So that's 10 radical 2 over 2. Now, what that did was it brought a 2 outside the radical on the bottom there. Now I can reduce the 10 and the 2, and that gives me 5 radical 2 over 1, or just 5 radical 2. All right. You will see those a lot. And then adding and subtracting, you won't see these a ton, but it's good to see it because it will happen occasionally. With adding and subtracting radicals, you can only put together radicals with the same number under the radical. So I can only put together 3 radical 6 and negative 1 radical 6, and I can only put together 2 radical 3 and 5 radical 3. And it's really pretty easy to do. You just add or subtract the numbers in front. So I've got 3, and that's a negative 1. So 3 minus 1 is 2 radical 6. And then 2 radical 3 plus 5 radical 3 is 7 radical 3. Can't put those together. That's my answer. Last one. These are not like radicals. Can't put them together, but 60 and 135 can both be broken down. I don't want to lose the 5 that's already on the outside, and I don't want to lose the 2 that's already on the outside. So I'm going to do that. And now I'm going to go break down 60. I'm going to do this again very quickly because I've done it several times already. Okay. So I've got a pair of 2s, which makes 2 on the outside. 5 and 3 are unpaired, so that's radical 15. Right. 135. I know 5 goes into it. How many times? Calculator. 27. 27 is 9 and 3. 3 is prime, and 9 is 3 and 3. So that's a pair of 3s with 3 and 5 left over. And look what happens. They both have radical 15 now. Before I do any subtraction, though, I need to multiply this stuff together. So what I've got is 10 radical 15 minus 6 radical 15, and you should be good from there and get 4 radical 15. Okay, let me know what questions you have. We will have a SWIC on this tomorrow.